In this video, we will learn two new Alteryx tools, the Multirow Formula tool and the Unique tool. Both of them are from the data preparation toolbox, or whatever you want to call these things up here. So I've made them both a favorite. Let's learn the Unique tool first. So here's our data, or here's our workflow that we've been working with in previous videos. We can run our workflow, and we'll look at the output here from this node, because these were just things we had taken. I had shown you how to do certain things with this, but this was our data here, our full data set that we have. Let's get rid of this. And let's suppose we want to know the unique values on this in this field, or for this variable. What are of all of our 466 individuals in this data set, what are their education levels? For example, is there anyone who has 4 years of education? So we can answer that question by using a Unique tool, and we'll move it up here. So Unique tool will have, here's the tool configuration. We just select which variables we want to find the unique values from. Let's just say education in years. And when we hit run, it's going to put the unique values in the unique output and the duplicates in the duplicate output. So D is duplicates, U are unique. So here are the unique values for education, and it sorts them once it gets them, puts them from an ascending order. So there's no one in here who has 4 years of education. There's a person who has 8 years of education. This is the first instance when it looked in the original data set. It must have been this person number 4, person ID 4. On row 4, there was a person with 8 years of education. It was the first time that Alteryx saw 8 in that column. And so forth. So you see how it does it. If we look at go back here, it looks in this column. It says, all right, 15. That's the first time I've seen a 15 on row 1. Person 1, record ID 1. So that'll be in the unique output. 16, that's the first time I see a 16. That'll be in the unique. 12 will be in the unique. 8 will be in the unique. It sees 15 again. That's the second time I've seen a 15. That's in the duplicate output. 15 duplicate, 15 duplicate. 12, that's a duplicate, because we already saw 12 up here, and so forth. So if we go look for 15 in the unique, it should be this observation right here, because it grabs the first one. Here's 15. Yes, it was that first person. And then of course it sorts it in ascending order by this variable. So we got people in here with 8 years of education, at least one person. Are there more than one person? Is there more than one person? Well, we look and see, are there any duplicates with that education level? So we go in the duplicate, and we look and say, oh yeah, there's lots of duplicates. A lot of people have 8 years, and so forth. There's at least one person with 12 years of education, at least one with 14, and so forth. So that's the Unique tool. The majority of this video, though, I want to spend on the Multirow Formula tool. It's a pretty powerful tool. For most of the things that the Multirow Formula tool you might think to use it for, you can accomplish, however, with the Summarize tool, which is in the Transform toolbox. And I already have it saved as a favorite over here somewhere. Yeah, right there. The Summarize tool will accomplish things like running totals, sums by category, counts by category, averages by category, the minimum, the maximum of a category of a variable. For example, if we look at our data here, and if we want, what's the average salary of the manual job category? Summarize will do that really quickly. But the Multirow Formula tool you can also use the Multirow Formula tool to do the same thing. And so I'm going to teach the Multirow Formula tool by doing a running total. Even though if I was actually doing that, I wouldn't use this tool. I would use the summarize tool. Or there's actually a tool called running total. But I would use one of those tools. But I feel like this is a good way to teach the multi-row formula tool and how it works. So let's do that. Suppose we want to know, let's attach a multi-row formula tool right here. We want to do it on this data right here. And what we want to do is we want to know by job category. We want to get a running total of the time on job in years so that we can get the sum, the total time on job in years for each job category. How many total years have the manual workers been on their jobs in total? Person 1's been there for 8 years, been at their job for 8 years. Person 2's been at their job for 15 years. So in total, they've worked 23 years doing manual labor total. That's what we're wanting. Running total. So we attach a multi-row formula tool to our data, and we can either create a new variable, new field. We could call it running total or call it sum, or we could update an existing field. I would strongly advise against ever updating an existing field. So what that would do is suppose we're looking at this time on job in years, and it would literally, we need people who are in the same job category. So these people here. So suppose this is the first person in the manual job category. Then this would say 8.17. If this is the second person, this would be the sum of this and this. So this would say, what, 16.34 and so forth. This would be 16.34 plus 8.17. But then that completely changes this variable. We'd have to rename it and everything. And it would be, we lost the data on this variable. We don't have this variable anymore. So I'd strongly recommend not updating an existing variable. So don't check this. Create a new variable. We'll call it sum. We want it to be the sum, the running total of time on job in years. Time on job in years, though, has decimals in it, right? Where's my output? Time on job in years, 8.17. You can see these decimals, 8.08. So over here, our running total of time on job in years, which we're going to call sum, we better not make it an integer data type. Otherwise, when you add 8.17, it's just going to round to the nearest integer. It's going to round it to 16. So we're going to make it double so we get the full 16.34, for example. All right. But now we want to group by job category. So this is important. Makes our lives so much easier. Group by job category. Make sure that's the only thing I'm grouping by. And then down here is the important part. This is where we write our expression. Don't really do anything here. And you can leave this as at its default usually. And I'll explain this here in a second. So basically we're writing an expression that we're going to evaluate for each row of our new column. To get each row of our new column. We're creating a new column. And we got to tell Alteryx what's row 1 of our new column going to be equal to. What's row 2 of our new column going to be equal to, and so forth. So it looks like row 1 of our sum variable should be equal to row -1 of our sum variable plus row 1 of our time on job in years variable. So here's the syntax. If you want the previous row of a variable, then this is the syntax. Row -1 and then a colon and then the variable name. Enclose, of course, you have to enclose it in brackets. If you want the current row of a variable, you don't put anything. You just put the variable name. And if you want the next row of a variable, you put row plus 1, colon, and then the variable. And so let's evaluate this expression for row 1. So row 1 of sum is going to be equal to this expression. It's going to be equal to row 0 of sum, so the row previous to row 1, row 0 of sum. Row 0 of sum doesn't exist. So values for rows that don't exist, we gave them a value of 0. So this evaluates to 0, 0 plus row 1 of time on job and years. That's exactly what we want. The first row of sum is going to be the first value in the time on job and years category. Row 2 of sum will be equal to row 1 of sum, which was just time on job and years, plus time on job and years row 2, and so forth. So this should accomplish our running total. When we change job category, it starts over. Row 1 of sum for the next job category is equal to row 0 of sum for that job category. That row doesn't exist for that job category, so that it would be 0 plus that row 1 of that category, the value in the time on job and years column. So let's run it. Let's look at the output. There's the first value in sum, 7.9. First of all, notice that it did sort our data by job category in ascending order. Why did it do that? Because we checked the box grouped by job category. So it's very important that you do that. It makes your life so much easier. So job category, we have 3 job categories: hybrid job, a manual labor job, and then an office job. And then we look at our sum variable. We have a 7.92. Then the second person, we add them. So row 1 of sum equals row 0 of sum, 0, plus row 1 of time on job and years. Row 2 of sum equals row 2 minus 1 of sum, or row 1 of sum plus row 2 of time on job and years. Row 3 of sum equals row 2 of sum plus row 3 of time on job and years. Row 4 of sum equals row 3 of sum plus row 4 of time on job and years, and so forth. It's just doing this formula right here. When we get to the end of the hybrid job category, hopefully it stops. Where is our hybrid? So row 27 of our data is the last row of the hybrid job category. And it stops. Row 1, which is row 28 of our data, but row 1 of some column for the manual job category, since we grouped by job category, it starts over. Row 1 of the sum column, which happens to be row 28 of the sum column for our whole data set, but row 1 of the sum column for the manual job category is equal to row 0 of the sum column for the manual job category, which doesn't exist, so we gave it a value of 0, plus row 1 of the time on job and years column for the manual job category. Row 2 of sum column for the manual job category equals row 1 of the sum column plus row 2 of the time on job and years for the manual job category. So row 28 of our data set is row 1 for the manual job category, right? Row 384 of our data set, that's row 1 for the office job category. So it should reset again. Yeah, it resets again. So that's that illustrates the multi-row formula tool. One thing you might want to do here, just out of curiosity, you could, what if I want to know the total number of years of experience for each job category. So I just want 3 numbers. There's the total for the manual category. There's the total for the office category, and then the hybrid category was what, 183 point something? The hybrid people in total have worked, where was it? It was on row 27. Yeah, 183.5. I just want those three numbers. Well, I could write another multi-row formula here. I could put another row, and I could create a new field. We'll call it result. It can stay an integer. That's fine. For result, though, we're not going to group by anything, and we'll write an expression. If, let's think carefully though what we want the expression to be. Right. So if, whoops, if the current row of job category, and this, what we're doing here won't necessarily work unless this data is already sorted by job category. And it is, because it's the output. This is the output of running this multi-row formula, and we sorted it by job category. So once it's sorted by job category, then this will make sense. Then we don't have to group by job category here because it's already sorted. So if job category equals the next row's job category, then this result, new field called result, new column called result, will equal 0. So if we haven't changed job categories, then we'll make this result equal 0. Else, if we have changed job categories, so if job category current row does not equal the next row's job category, then let this current row of the result field equal 1, end if. So essentially, this finds the end of each of the job categories. Finds the last row in each of the job categories. So you see there's a bunch of zeros, and then on row 27, since that's the end of the hybrid job category, it puts a 1 here. So basically, at the end, what row was the manual job category did it in? I think 383. Yeah, row 383. That's the last row of the, and right beside it, is this total sum. That's what we want. So then all we have to do, and then the last row of the office job category is the last row of the data set. Notice that our formula works for the last job category as well. If job category, so if your office job category, and we look at this last row here, does, where is it? Yeah, does this row of job category equal the next row of job category? No, the next row of job category doesn't exist, and we've given that a value of 0. So does the string office equal the number 0? No. So we're in the else condition. We're putting a 1 here. If it did equal, we put a 0. So now all we have to do is put a filter tool on our result column and filter out the 1s as the true and 0s as the false. There's only three that are true, right? And that'll give us our sums that we wanted. So we just filter on our result column. Result equal 1. The output where that's true will go here. The output where that's false will go here. So here are our 3 rows where the result column equaled 1. And we know that those rows contain the sum, the largest sum, the running total. So this is the total number of years that the hybrid employees have on their jobs. This is the total number of years that the manual employees have on their jobs. Of course, it's much bigger. There's a lot more manual employees than there are hybrid or office. And this is the one for office. So this way we can get, looks like we use this multi-row tool to get a running total. Then we used another multi-row tool and a filter to get the actual sum for a given, the sum of this variable, time on job in years, by job category. You can do this exact same thing with one summarize tool. One summarize right here. you can do what we did in these three tools with one summarize tool. And that's the way I would do it. But that just illustrates how the multi-row formula tool works. All right, one last thing I want to do is also with a multi-row formula tool. So one thing you cannot do with a summarize tool, and I don't know why they have not added it to Alteryx. People on the Alteryx forum have complained about it and said, why haven't you added a running product or a total product to the summarize tool? What you can't do is you can't find a running product or a, let's go back to our original data. Let's go back to where we actually had it sorted here, just so you can see. So what you can't do is you can't find a running product, or like what's the product of time on job and years for each job category. The product, like multiplying. So we want to create a new variable. Instead of sum, we want to create product. So the first number here will be this number. And then the second number in the product category will be the product of these two numbers, not the sum of these two numbers. The third number in the product category column will be the product of these first three numbers. And then when we get to the end of the hybrid job category, we'll start over for the manual job category. So exactly what we've done using sum, but we want to use running product. You can't do it with the summarized data tool. The only way you could do it was that I know of, and there's probably other ways, but the multi-row formula tool. And the reason I'm teaching it here is, well, one, to illustrate the multi-row formula tool again, what else it can do. And two, you're going to have to be able to calculate a running product with data later in the course when we do another case, when we start doing our cases that we're going to do. So it will come in helpful there. So let's attach a multi-row formula tool to, if you try to get it too close to any given tool, it wants to attach to it. But I want it to attach to this one. And then I can move it back over here so it's not so far away. And so I want a running product by job category. So first, see the job categories it's not sorted by job categories. So I have running product by job category of time on job in years. That's what I want to do. All right, so our new field is going to just be let's call it product or running product. I'll just call it product. It's going to be not an integer because it's the product of decimals, which is also going to be a decimal. So we're going to make it a double. Values for rows that don't exist. We're going to change this to null. We could keep it 0, but then that would change our expression down here, and you'll see why here. We're going to change it to null. Right, what we're going to do is we're going to write an if-then statement. If is null, which is a function, is null of what? Row minus 1 of our product column. So if it's null, then let current row of our product column equal time on job in years. Else, if the previous row of the product column is not null, then let the current row of the product column equal the previous row of the product column multiplied by the current row of the time on job in years column. End if. And hit run. Let's look at the output. Then we can verify. Oh, I already see a problem. We did not group by, so that's going to mess everything up. First, group by job category. Otherwise, it's going to be calculating products across job categories, and we don't want that. Now run. The reason I knew it wasn't grouped by job category is because the output, it wasn't sorted by job category. So there's the output sorted by job category, and here's our product column. First row is first row of time on job in years. Why? Because the previous row, which was row 0, didn't exist, and values for rows that don't exist we set equal to null. So is null of row 0 of the product column evaluates to true. Then that means row 1 of the product column, the current row, should equal row 1 of the time on job and years column. And it does. When we move to row 2 of the product column and evaluate this expression, if is null of row 1, so row 2 minus 1, row 1 of the product column, is row 1 of the product column null? No, it's not. So we're not going to be here. We're going to be in the else category. Since row 1 of the product column is not null, then that means row 2 of the product column is going to equal row 1 of the product column, this row, times row 2 of the time on job and years column. Row 3 of the product column equals row 2 of the product column times row 3 of the time on job and years column. In other words, this equals this. This equals these two things multiplied together. This equals these 3 things multiplied together. This equals these 4 things multiplied together. We have a running product. And it starts over when we start the new job category, manual. And it should start over when we start the new job category of office on row 384, if I recall correctly. Yes, starts over because we moved from manual to office. So the multi-row formula tool is very powerful. It can be used to calculate running totals, averages, counts, minimums and maximums if we wanted to, products. Hopefully you guys take some time. You can pause the video, go through these formulas that I've written, these expressions, and make sure you understand why they work. And you've understood the importance of data type here and also the grouping by. Just as one last thing, if I made this an integer, that means the product, well, let's just see. I'll show you. If we look at the output, everything's just going to be, it's going to round to the nearest integer. So this is just this rounded to the nearest integer. This is the product of these two numbers and then round it to the nearest integer and so forth. It looks kind of cool with like a pyramid here going on, but I see a null value. I'm not exactly sure why. Probably because it got, oh, I know why. It got too big for the amount of space we have. So that concludes this video.